So here is the other way of storing our graphs using different data structures. And that is a vector of adjacency linked lists. So think of it this way, is that, well, same graph, same data, but this time we're going to be using a vector for all of the vertices instead of a matrix, but then they're going to be linked to a linked list of, frankly, what numbers they can reach. So if you look at the graph, 5 can get to 1 and 5 can get to 4, and there it is represented in the overall graph. And the nice part is you're definitely used to vectors. You guys are used to linked lists, so this isn't very hard. And again, the beautiful part is that's the graphical version of it. This is the data version of it. And we know how to manipulate both a vector and a linked list. But also notice this saves so much data than a matrix if it's a rather large graph. It's a much shorter, to the point, and I'll just leave it at that. So I think you can figure out which one's my favorite. Now, how would I find a path from 2 to 1? Well, frankly, I would go to the vector 2, then have it reach and say 4, and this would be recursive. 4 go to 3, 3 go to 2, and well, that's a cycle, so that's a problem. The 2 go to 4, and then remember we actually had 2 options at 4, go 5, 5 go to 1. So this sort of sounds like what we did with disjointed sets, right? So we would have to do some interesting algorithms on exactly how to find our path from one node to another. Now, does the order of the values after the key in green matter? The answer is really no, but it's not a bad idea to have some type of order with it when you are adding your data to the linked list. And again, you guys know how to do that already. So while it's not mandatory, I would highly suggest it. Let's just put it that way, because you may be able to do more of a search in that way, again, if it's in some type of alphabetical order or something of that nature. So in this picture, it happened to be ordered. Doesn't have to be, but notice I'm kind of chagrining at that. So here's another example of a vector of an undirected adjacency list or linked list. So again, here's the graphical representation, and here is the, well, how we would actually store it. Now notice, by the way, I'm adding weights this time, and as you know, with the linked lists and nodes and stuff like that, it's really easy to add very easy data members like weight. So notice that the weight would now be stored in the nodes themselves to again represent this graph, and that ain't hard. So it's nice and easy to work with when it comes to using vectors and linked lists just to represent our visual representation of a graph.